Hi class, it's Bill Berry here with a video on creating databases, tables, and indexes. Recently we explored design. We talked about how to take client artifacts and read narrative and try to figure out how to create a normalized database for that particular use. That's great, and now we're going to move forward in learning how to do the SQL that actually creates that stuff. I think this is important for several reasons. Yes, we want to explore the SQL syntax here, but also we understand the full circle of the database world once we do this. Part of that is, from the very beginning, we've been talking about primary keys, foreign keys, and we've understood those essentially, but since MySQL and most SQL versions use what's called declarative referential integrity, integrity is kept not based on some vague notion or programmatic means, but it is actually declared as part of the syntax, right? That's the declarative part of declarative referential integrity. So we will see when we create the tables that we are literally declaring the relationships. So you will see everything spelled out really specifically, and I think that helps us to really cement that knowledge of how SQL implements these foreign key, primary key relationships, etc. So let's jump into that and explore that today. First thing is, remember that we are now in the DDL world, data definition language. We've spent most of our time focusing here, right? Queries and adding and editing data, etc. But now we're going to learn how to do definitions. So in DDL, data definition language, we learn to create schema. How do you create a database? How do you create a table? How do you set up constraints? How do you create indexes? All of that stuff is part of definitions, right? We're working with schema. Let's take a quick peek at some useful EERs just as a reminder. And this one is for our pet adoption. So for the class examples, I'm going to use this. This should look familiar. There's a many-to-many relationship here. We're assuming some pets come back, right? Not every pet gets adopted successfully, so they come back. So they may have more than one customer, more than one adoption date. So just pay attention to that. Screenshot it if you think you need to. Another one that we've been using, this is part of our design output from the design lesson, and we created an EER during this exercise for membership in this PTSA, Parent Teacher Student Association, focused on the member table. Then we have some committees over here. We have some offices like presidents and vice presidents over here, and then we have stuff about dues over here. So we'll use this. In fact, we're going to focus, as we'll see in a minute, we're going to focus on the members and committees because we don't need to create this whole thing in this video. But we'll focus on this as our exercises. So in class, we'll focus on that. All right, so first let's review a couple of very simple operations to create databases. So to create a database from scratch, you do create database or create schema. Remember, these mean you got to pick one. This means it's an or situation, so pick either database or schema. So we say create database or create schema. Optionally, we can say if not exists, and then we give the database name. You can drop a database the same way, drop database or drop schema. If exists is optional, and then you give the database name. Of course, we know how to use to set the default, and you can also say show databases. We know that we can do that with the schema navigator, but sometimes it's useful to be able to do this from a command line. So again, there's a note here I'll let you read regarding what schema means, but let's look for a minute at this stuff. Why do we have this if not exists and if exists stuff? The reason is because when you write these things, you are typically creating a script. If you think about the sample databases that come with SQL or that come with our textbook, most of them need to be able to run top to bottom, and they need to run whether or not the thing existed before. So these syntax pieces that say if not exists and if exists are there to make sure that your script runs. Because for instance, if you say create database and that database already exists and you do not include this optional piece, then what happens is your script will abort. It will stop, terminate, and give you an error message. So we need to make sure that our scripts always succeed, regardless of whether the user runs them with or without the thing existing to begin with. So that's important for scripting. If you're just writing it yourself, you may not include that, but when you're writing a script, think about the if not exists and if exists. In fact, typically we're going to see that we always start with a drop database to kill the thing, and we always want to make sure that we do it correctly, right? We don't want it to error out if it doesn't exist. So we'll look at that a little bit more, but it's script reasons that we don't want scripts to terminate and not complete if the thing exists or not to begin with. So let's also review a couple of table operations. You can rename a table if you need to. You can delete the table, but not its data. So pay attention, right? Or not its definitions, rather. Truncate table will delete data, but never schema, whereas drop table also deletes the definitions, right? So this is a little more serious, right? Drop table will delete the actual table definition. The columns and everything go away, the column definitions. If we just say truncate, the thing ends up empty, but still existing. And you can also say show tables if you want to see what tables you have in your database. So these may come in handy. Now we're getting into some syntax that's the most intricate that we will see all quarter, right? This is the hardest syntax of anything, but it's also kind of the most important, right? It's the key of creating all of this stuff. So let's look at some of the syntax for creating a new table. You say create table, no surprise. You give it a name, no surprise. Then we're going to focus first on the column business, right? So what you do is you list the name of the first column, you give its data type next, and then you may give one or more attributes for that column, right? Now notice those are space delimited. There's no comma in between those attributes. And then if you wish to go on with the second column, then you put a comma, right? So commas are for delimiting the columns, not for delimiting data within one column. So you notice all of this is space delimited. So column name, put some tab, space, whatever you want to do, some white space, and then you go on with the type and then the attributes. And you can give a lot of attributes if you need to. So let's focus on those columns for a minute. What are the common column attributes? You know, we see attributes here. What are common ones? Well, down here, not null. So if you wish to, you can say you want to make the column not nullable, and then the user can't skip the data, they have to include it. Also, if you want to be explicit, you can use the keyword null for columns that you want to specifically allow to be null, or you can simply not include the attribute at all, and the default is going to be that they're nullable. So not null or null. You can say unique if you want. That is for columns that are not primary keys but still need to be unique. It's rare that you use that separately, but you might be able to. You can say default and then give a default value. For instance, the default for this particular column is going to be $0 for a customer balance or whatever you want to do there. Default date, whatever you want to do. You can also say primary key is one of the attributes. This will only, though, work for single column keys. If you're going to do composites or foreign keys, we'll learn that later. But for a single column primary key, which is really typical in a lot of tables, you can simply say primary key. You can also say auto underscore increment to make that column be auto increment. Notice though, this one uses an underscore. Why does this have an underscore, whereas this doesn't have an underscore? Why does this not have an underscore? I don't know. I didn't make it up. It's not consistent. Seems silly. Yes, I know, but that's the way it works. Now, there's some rules for that. It can be an integer or a floating point value. It has to be a PK, right, a primary key, or marked as unique, and you can only have one per table. So you can't have multiple auto increments per table. You can, in the reference slides, see how to start this with another number. For instance, if you're generating customer numbers, you might not want them to start with 1. You might want them to start with 1,000 or something like that, right, to be a little higher. So there are some of the common attributes that we can use when creating a table. So let's look at an example of how we would do that. Using that syntax, how would we create this customer table here? So let me now run over to grab my little handy notepad editor here. So I'm going to put this here and we'll write this together. Okay, so we want to create the customer table. So obviously we're going to say create table and then we're going to give it the name customer. Then notice we're going to have parentheses. So I'll do it here just to save some space, and then in the end we're going to have this, right? We know at the end we're going to come back and we're going to need that close parentheses. In here now we can describe the columns. So what's the first column name? Cust ID. What is its data type? That needs to come first. In this case, it's an int, right? So I'm just going to put int. What kind of attributes need to go here? Well, you'll notice over here looking at the EER, this is a primary key. So I'm going to say primary key. What else do I need to say here? Well, that probably kind of solves it, right? Oh, wait, we want it to be auto increment. Let's just assume we want these keys for this this particular thing to be auto increment. So then somewhere over here I can say auto underscore increment. Once I finish with this column, then I can put a comma. Now, some people, instead of putting a comma at the end of the line, will put a comma at the beginning of the next line because all the subsequent ones need a comma, but you can't put a comma at the end. So this is actually not an uncommon way to do it, where they go on this way, right? So whichever way you like better, you can certainly do that. Next column is going to be cust name. What is the data type for that? Varchar 50. Right? What kind of attributes does this have? Well, it looks like based on the EER that should be not null because the little diamond is filled in with teal, turquoise, whatever color that is. Little turquoise diamond is filled in, so that means that is a not null column. Again, put a comma and then we go on. What's the next one? Cust phone. Let's see, that is going to be a char 10, great, but that one is nullable, so I either can say null or I can just do this, right? I can leave it out altogether, and that works fine, but I'm going to be explicit and I'm going to say null. And what's next? Cust balance, and that's going to be decimal, let's say, and maybe 6 comma, you can't read it there, but let's say 6 comma 2, and that looks nullable, so I'm going to say that, and based on the bullet point above, it should default to 0, so I'm going to say default 0.0. Okay, that wouldn't hurt anything. Notice we can't put a comma here, right? You can't put a comma after the last item. You must use it as a separator. Now, if you want to be kind of careful about things and make things look pretty, of course you can line things up. Let me do that real quick and I'll come back. So something like this makes everything lined up and easy to read, but that's, SQL doesn't care. For the humans, maybe that's a little bit easier. So that's the kind of SQL that we would create to create this table. Now, we have set the primary key, so that's all good. So really, that's pretty good for that table, right? We don't really need anything else. So that's the SQL that you'll want to do. Notice that when you, run that, when you run this in MySQL Workbench, you're going to see a thing that says 0 rows affected because really no data was happening, or maybe it says 1 row because it added a table, but the output that you get from it is not anything special. As long as it doesn't give an error, then you're okay. Now, if you get an error, then you need to go through and figure out what's wrong with your syntax, and sometimes it's not very helpful in this regard, so you just have to go check very carefully. Do I have my commas? Did I list the data type first? All that stuff, right? You got to go and kind of figure out what's going wrong. But once you get that working and it works correctly after you execute it, then you can refresh your table list in the Schema Navigator and you will see that table showing up. And then you can add data to it if you want. So that is the main point here in creating a simple table. Right? So there is the sample code here. Now, one other interesting thing, this is just a little side thing for you. If you wanted to create timestamp columns, which are really typical in professional databases, you want to know what time and date the last time this particular row is edited or added, right? When did this appear or when did this get changed? You can do this by using a timestamp data type or date time data type. Either one works fine. And here's the interesting syntax you can use here. This is just a column name, whatever you want to call it. And then again, timestamp or date time, either one, doesn't make much difference. And notice you say default current timestamp and then on update current timestamp. So that says when the thing gets created, put in the current time, and if someone updates this row, put in the current time. So that's a very clever way to do this. Again, this is not a magic keyword. That's just whatever you want to call the column, and then the rest is pretty cool. So of course there are things that you can follow up on if you want to learn more about it, but that's just kind of a fun piece. All right, so what we've learned now is we've understood how to do the basics of columns, right? How do we create a table, and how do we set up the basic things about columns and their attributes. But what we're going to learn next is important because not everything can be done as a column level attribute. We know, for instance, that composite primary keys cannot be set up that way. Foreign keys cannot be set up that way. So we still have things to learn about constraints that are created not at the column level, but as what's called table level constraints. So we're going to pick that up in the next video and learn how to do table level constraints and do some samples with that. So thanks for watching this video. Continue on to the next if you want to continue learning this topic.